So hi guys, it's been a very long time since I made a video in this channel. So today I plan of making a video about how I made a compiler using C from scratch. So firstly, I haven't watched any tutorials for this. Second, I only followed some links online, so I would just go to Google and search how to make a compiler from scratch using C, but I tell you, you won't find anything regards to compiler, but just dig deeper and read some documentations and learn how languages are made, and from there you can easily catch up on how to make a compiler. So this is the GitHub repo of mine about the call compiler. So the language that I'm using here is known as Golang. Golang, how good is that? How great it sounds. Okay, so the Golang, which is similar to Golang, but it's using animals, so Golang, whatever. So welcome to the call compiler. This is the documentation I wrote, but modified using ChatGPT, because I can't just type everything in the GitHub README, everything, because it's large, and I made it open source so you guys can fork this and use it on your own. You can develop it. That's what developers do, develop. Okay, so let's move on to the compiler. So it's a lightweight compiler, as I said before, written in C. And the main thing about this compiler that I made, that it uses an intermediate representation known as LLVM. So LLVM, guys, is known as low-level virtual machine. So it's basically like a framework, like a structure, which the current code that is compiling before converting to assembly will convert into an intermediate representation for improving its speed and functionalities and everything. So that's what I use here, the LLVM IR. And the project complete compilation pipeline. So firstly, what I did is I made a lexer. So it tokenizes the input source code. So let me just go to so this is the entire code. So before getting into all this, I want to show you guys the structure of this code, this GitHub repo. So firstly, we are having three things, which is front end, middle end, and the back end. So in the front end, we're having lexer, parser, AST, which is abstract syntax tree, and token. So in the lexer, we are going to do the lexical analysis, which is converting the entire code or text that you have written into a piece of token, which is basically made using enum. So we will see that in the code, and the parser for the syntax parsing, and AST. So basically I made this AST as a separate folder so that I can use that functions in the parser. And token, as I said before, the enum tokens are located in here. And in the middle end, we are going to make the IR representation and the IR generation. And in the back end, we are going to use the LLVM and the evaluator. So LLVM is the thing that's going to generate the IR, as I said before. And the evaluator I made before implementing LLVM, so to check my code, whether it's working or not, because I make a lot of bugs and I'm doing this without any tutorials. So yeah, you know, I do made a lot of mistakes and I learned from them. So I can be a better developer or something. What am I speaking? Okay, moving on. We are having test, but there is no folder called test. I just made it so that you guys can put the text in there. And the source folder, which contains the main C. And then make file for building the system using C, so that you don't need to write every file on the terminal itself, and a readme file. So join the discussions, guys. I've made a discussion forum for you so that you can just talk anything about compilers, and you can even mock my code. You can just say anything about compilers and my code. You can say how dirty I wrote this code, how I killed entire C, or how I made it beautiful or wonderful. It's up to you guys. You can use the discussion forums here. You can just post anything. Okay, moving on to the code. Yeah, code. So that's the project structure, and you can join the discussion. If you're a contributor, I welcome you to the cow compiler. Welcome, guys. And the most funny part is there's another language called cow. I think a cow compiler or something. Yeah, you see, there's another cow compiler. I just named it randomly cow because I always get this moo moo sound when I wake up, because there is a cow farm nearby my house. So yeah, there's a cow compiler online. So guys, there is a language called cow already, and I don't know why I named it cow. So yeah, it's cowlang. Okay, moving on. So the input, guys, so this is the input, but you just have to make it let. You just have to use let here. So I just made it simple for you guys to know. So for running this, make run using makefile, and that's it. So let's move on to the features. No, for the compilation pipeline. So firstly, we are having lexer, which is going to tokenize the input source code, and we are having parser, so it will parse the tokens using the abstract syntax tree. And the abstract syntax tree, we are going to represent the structure of the program, right? So using this abstract syntax tree, we are going to recursively search through it. We are going to find the functions, and we will see that I just implemented a binary tree for this to work, for a binary representation, of course. So yeah, and the intermediate representation using so it's just basically the function that does have the syntax of LLVM. So then the LLVM code emission and blah blah blah, that's it. So this is the README code. Let's move on to the code. So this is the front end. Beautiful front end. So let's move on. First, let's see the token.h. So these are the tokens that I've implemented for my compiler. So there are lots and lots of tokens, but this is small when compared to a huge language. So yeah, so these are the tokens. So I've implemented like half of this, the if while function, L parenthesis, R parenthesis, and L braces. I haven't implemented this. It's for you guys. You can implement it. So basically, we are having a course, I think, during the 6th semester known as Theory of Computation, where we will learn about compilers and everything. But I just want to be quick. I just want to learn about compilers because I think that's fascinating to know. And yeah, learn compilers. That's so that you can just brag about yourself among friends. Hey, I made a compiler, even though it's simple. I just made using C. I haven't used any fancy languages like Python or Java or something. I use C, just like that. Okay, so this is the token, and in the parser, you're going to have the following functions. So let's just move on to the lexer first, and then let's see the parser. So in the lexer, I implemented the tokenizer function. So it's just going to tokenize the thing. So if, let's see the input file, I think I made a commands.txt. No, it's not here. So I think here. So test.cow. So we have used let x equals 4 plus 4. So it's going to declare a variable, and we are going to get the output as 8 here. So yeah, that is the thing. Okay, let's move on to the lecture part. So it's going to just it's going to break down that let x equals 4 plus 4 into let means it's a variable declaration. It's a variable what I made it here as token let. It's known as token let, and it's used for declaring a variable. And then we are having an identifier, which is the variable name, and the token minus token plus. So guys, imagine this. It's like separating ice creams into their different flavors to their separate boxes. That's it. That's tokenize. That's Lexer, which just tokenizes everything. And moving to parser. So in the parser, we are going to make the abstract syntax tree for evaluating everything, every tokens that we have made. So it's just a tree representation of tokens. So firstly, we are going to have a variable, then 4 and 4. Wait, I'm having a plus sign here. Yeah, so plus sign 4 plus 4 8, which just assigns to the variable x, and we are going to get x equals 8. That's it. That's what I did here in the parse expression. I think God, it's sweating here because I turned off the fan because of its noisy sound. Yeah, so parser is just going to create the abstract syntax tree. That's it. In the AST, yeah. So these are the variable node declarations that I made. So the number node, the variable declaration, binary node, and free AST. That's it. So that is AST and error. You know, this folder is so funny because I made it error so that people will think that, oh, it just emits error. Obviously not, because I made some errors when I was writing the lecture parser and the abstract syntax tree, which is the most frustrating part of this compiler because I don't know what I was doing, but I just have to implement it. So that was really frustrating, yeah. So this error folder, I made it because so that I can rectify my error of parsing AST. So guys, this has nothing to do with any of the program, but if you want to check your lecture parser AST before converting to LLVM format, you can check this. So it's good. Yeah, that's the front end, guys. I think I covered everything. And then moving on to the middle end, the IRC, our hero here. So IRC. Yeah. Okay, so basically in the IRC, what I was doing here is I'm just converting this into the IR format, which is a series of, you can see here. So I made a tokenizer to tokenize the input. I made it to the abstract syntax tree so that it can make into a tree format, and I parse that tree and send that input to the IR format in the middle end. So in using IR representation, it's going to convert that tree syntax into its own form of tokens. Like, it's not tokens, but it's representation, because each language you can just directly convert that abstract syntax tree into the LLVM syntax, which is, I think I can show you here in the back end. I think in the LLVM, see, yeah, you see here I made some def1 i32, which is integer 32, I think, and the main function. And I made some series of this, what is that, %s, or just the string and the value for getting in here, right? So this is the syntax of, okay, let me just Google it. Why am I blabbering about it? LLVM syntax, let me just Google it. So here we go, yeah. So it's a huge documentation, of course. Let me just see, where is the function attributes? Yeah guys, see, this is the syntax of the LLVM. define void. There are some optimizations in LLVM, such as you can just if you declare a for loop and you're doing some computations to get a particular value of x, LLVM just directly assigns x before doing some computations. That takes a lot of time. I think that's some optimization levels, and there's huge things in LLVM. So I'm just touching the tip of the iceberg here. So yeah, I just came to know about LLVM, how it works. I made a compiler. Yeah, so yeah, there is some optimization using threads and everything using LLVM, using that thing. So you can just go and check it out. Okay, moving on. So that's how we make the LLVM function in the IR representation. So as I said before, many languages have their own IR representation before converting into that LLVM cryptic syntax that we've seen before, that define, main, I32 may. So yeah, this makes that, as I said before, like the while loop thing and the whole optimization thing. Each language can do that specifically. For example, Shift, I think Shift has an intermediate representation. I think Shift does that 2 times. Yeah, 2 times. They're making that into, before converting that into LLVM code. Yes. And the thing about LLVM is that it can run in multiple architecture, just like Java and Shift and Rust. Yeah, so they can run in multiple architecture, machine independent, run on anywhere, write once, run anywhere, something like write once, read anywhere, I guess, something like that. So yeah. So that is the IR intermediate representation, which is the generation. So here for generation, I made a linked list so that you can get a clear representation of the intermediate code, which is IR variable, IR assign, IR value. So it's going to be a linked list. So I'm going to send this linked list into the backend for the LLVM generation. So this A is an evaluator. For evaluator, before making LLVM, I just want to check my code whether it emits assembly or not. So I just made evaluator to evaluate the assembly code. I just think I removed that for the assembly generation. This is the test.assembly. I obviously removed it. So using LLVM C, let's see LLVM. So I basically use a switch case. Come on, you can use LLVM function. LLVM has a library in C. You can implement this, guys, using LLVM libraries, of course. So I just made a switch case here for the constant, add and subtract. It's gonna show you the LLVM code. And that's it. You can run LLVM using Clang. You can run that using Clang for the output emission, which is going to be 8. Yeah. That is the entire thing about my cow compiler. That's how I made it. So yeah, if it's long, these are the contribute, covenant, code of conduct. You can just read to this. Obviously, if you want to contribute, just contribute to it. There's no need for reading. I know it's just for the formality and security, blah, 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 QAMU. So NASM, as I said before, I'm making assembly. And for the assembly, for running the assembly, I've used NASM before, and QEMU emulator for running the assembly. Yeah. So I was writing the assembly in x86, but I'm using Mac, which is ARM, which is running on ARM. So I've used QEMU for emulating x86 to run my x86 assembly. I could have just write it on ARM. That's why LLVM is the king, guys. LLVM can convert to any architecture it wants, right? So yeah, guys, this is the video about what the hell is build. Okay, yeah. So in the build, I'm going to have the C.O file in the .o files. So yeah, so that's the thing about my compiler. So if you guys have any more to add, just for the repo, it's yours. You can add more about anything with regards to compilers, of course. And you can roast my code. Of course, I love roasting my code from you guys. That's funny. That was meant to be funny, but it's not. Oh, I hate how I write it, the code. But it's amazing because I made it from scratch. I don't know anything about compilers before this one. I learned how languages works, how compiler compiles the language, how assembler works and everything, because I want to learn how everything works. That's it, guys. Learn curiosity. Yeah, so that's it for today's videos, guys. I hope you enjoyed it. And it's been a long time since I made a video. As I said, video on this channel, I said before. Yeah, for this repo, I will leave the link below. You can do whatever you want, change this. It's just like a GitHub template thing. You can improve this, send it to your friends, share it, like, and subscribe. Thank you, bye-bye, see you on the next video.